Okay, so a video on quadratic inequalities. So last video we looked at linear inequalities, which were quite easy to solve. It wasn't much different to solving an equation. You had to be careful when you would have times or divided by a negative number. This time, however, it's quite different. So a quadratic inequality can be written as ax squared plus bx plus c, and then an inequality symbol, which is one of these four, so less than or equal to, greater than or equal to, or greater than, one of those four, 0. Okay, a quadratic inequality can be rearranged to arrive in this form. And then what I would do from here is I would take this and I would just quickly solve the quadratic equation ax squared plus bx plus c is equal to 0, which we can solve because we've done solving quadratic equations. So that's going to give us two answers. Let's call it x1 and x2. And then what I would do from there is very quickly just sketch the quadratic. Okay, so positive quadratic, it would do that between x1 and x2. If it's a negative quadratic, it will obviously be upside down, x1 and x2. And then I can just read off very quickly from the sketch whether I want in between the two values or either side of the two values. And that'll become clearer when I do some examples. But that's my general method of doing it. There are a couple of other ways of doing these, but these are the ones that I'm going to be teaching today. Okay, so first example then. X squared plus 3x minus 10 is less than 0. So what I'm going to do is I'm just going to solve the quadratic equation x squared plus 3x minus 10 is equal to 0. So x squared plus 3x minus 10 is equal to 0. So it's a change in the inequality symbol for an equal symbol. And you can solve this a number of ways. You've got factorising, completing the square, quadratic formula, trial and error, calculator. There's loads of methods you can use. It's going to be x plus 5, x minus 2. It's a factorised form. That equals 0. So this implies then that x must either be minus 5 from the left-hand bracket or positive 2 from the right-hand bracket. Quick sketch of this quadratic then. There's my x-axis. It's going to cross at minus 5 over there. It's going to cross at 2 there. So my y-axis is going to be about there. It's a sketch. It doesn't really matter exactly what it looks like. But as long as you've got the general shape with the roots. And at this point, we now go back to the inequality. And we want the quadratic to be less than 0. So for the quadratic to be less than 0, it needs to be below the x-axis. These are less than 0. These are values where they are less than 0. Here it's greater than 0, and at 2 and minus 5, it is equal to 0. Now we want strictly less. We don't want to include 0, so just as the notation I used in the last video, got the hollow circles there. So that's what the answer would look like on a number line. Between minus 5 and 2. Well, if I'm going to write that as an inequality line, it'd be minus 5 is less than x is less than 2, or I could write that in set notation, which is going to be x such that x is greater than minus 5 and x such that x is less than 2. Okay. So those are the three ways of writing solutions. Just don't forget that at A level, if a question asks you to write the answer in set notation, you must leave it in set notation. Okay, it's this one here. If it doesn't ask you for that, then this is absolutely fine. Okay. All right, second example. Okay, so again, I'm going to take the inequality. In this case, it's minus 2x squared minus x plus 15 is greater than or equal to 0. And I'm going to solve the equivalent equation. So minus 2x squared minus x plus 15 is going to be equal to 0. So I'm going to use a quadratic formula on this one. So x is going to be minus b plus or minus the square root of b squared minus 4ac. So that's going to be plus 8 times 15, which is 120. And that's going to be all divided by 2a, which is minus 4. Okay, so that's my quadratic formula. So root of 121 is 11. So 1 plus 11 is 12. 12 divided by minus 4 is minus 3. And then 1 minus 11 is minus 10. Minus 10 divided by minus 4 is positive 5/2. So those are my two roots. Again, there are other methods you could use to get those two numbers. Okay, so quadratic curve, it's now going to be a negative quadratic because the coefficient of x squared is negative, so it's going to be an N shape. It's going to cross my x-axis at 2 points, which is going to be minus 3 and 5/2, or 2.5. So the peak in the centre is going to be about there. But again, it doesn't really matter about the sketch and what the y-axis is. And now that we've got the sketch, we go back to the quadratic. We want when the quadratic is greater than or equal to 0, and it's going to be greater than or equal to 0 when the curve is above the x-axis. That's this part of the line. And this time we want to include when it equals 0. So we're going to put solid circles here and here. So it's all the numbers in between those two, including those two. So the answer then is minus 3 is less than or equal to x is less than or equal to 2.5. Or in set notation, it's going to be x such that x is greater than minus 3 or equal to, and x such that x is less than 2.5. And that is that's my answer in set notation. Okay. All right, a couple of trickier ones then. Example number 3, x squared plus 8 is greater than 8x minus 4. So we first of all need to do a little bit of rearranging to get it into the quadratic form first. So to do this, I'm just going to put everything on the left and leave a 0 on the right. So I'm going to get x squared, subtracting 8x from both sides, we'll bring it over here. Add 4 to both sides, it's going to be plus 12. And then that's now going to be greater than 0. I want to solve the equivalent equation, so I'm just going to change that inequality sign for an equal sign. So that gives me that. And now I'm going to solve that equation. So it's going to be x minus 2 times x minus 6. So therefore my x solutions are 2 and 6. Which means when I come to draw my quadratic curve, it's going to cross the x-axis at 2 and 6, and my y-axis will be to the left of both roots. Okay, so there's my sketch. Now, back to the inequality, now that I've got my sketch. I want this quadratic to be greater than 0, which means it's going to be satisfied by this branch and this branch. So my first two examples, the range of values of x were in between my two roots, but in this example, the range of values of x I want are either side of my two roots. I don't want to include the roots because it's strictly greater than, so therefore it's going to be hollow circles, and they're not going to join up, they're going to go the other way, so that way and that way, indefinitely. So if I'm going to write them as inequalities, as solutions, I want x is less than 2 or x is greater than 6. And you've got to use the word or if you're going to write them as that. Do not write 2 is greater than x is greater than 6. Because there's no values of x which satisfy that, because x cannot be less than 2 and greater than 6. So do not write that. That is really bad, because that is an empty set. There's no numbers there. Okay, no numbers satisfy x is less than 2 and x is greater than 6. So you've got to write them as two separate inequalities and separate them with the word or. And this is why set notation is slightly better, because we have x such that x is less than 2 or x such that x is greater than 6. It looks exactly the same as an answer would if it were including the two, except this is now the other way up. Oops. Having not written it the other way up. Or that, so it's either one of those two. And then finally question 4, this is probably one of the hardest ones that we're going to come across in year 12. We've got 3 over x plus 3 is less than or equal to 2. Now again, there are a few different ways of solving this. But if this were an equation, the first instinct would be to times by x plus 3. Now the problem is with timesing x by x plus 3 is we don't know if x plus 3 is positive or negative. So if you're going to times by x plus 3, you need to consider cases when x is positive and when x is negative. And that is possible to do that, but you're creating work for yourself which may lead to errors very quickly. It is better to times by a number that we know is positive. So what I'm going to do is I'm not going to times by x plus 3. I'm actually going to times by x plus 3 squared. Because whatever number you take, if you square it, it cannot be negative. So we're not going to have the issue of timesing or dividing by a negative number. Okay, so that's my technique I'm going to use here. So the left-hand side will become 3 over x plus 3, because one of the x plus 3's will cancel with the bottom. And the right-hand side will be 2 into x plus 3 squared. That takes both of them, both brackets. Okay, so that's what would happen there. And I'm doing that because x plus 3 squared is definitely not negative. Okay, so there's no issues. Now I'm going to multiply out the brackets. So I'm going to get 3x plus 9 is less than or equal to 2x squared. I'm going to get a 6x from the brackets, so it's going to be plus a 12x. And I'm going to get a plus 9 times up by 2 is going to be plus 18. And then rearrange that. I'm going to get 2x squared. 12x minus 3x is 9x. 18 minus 9 is 9. And that's going to be greater than or equal to 0. Okay, so I have swapped the sides of the equations there. Because it would be 0 is less than or equal to 2x squared plus 12x plus 18. Okay. Now that I've got that, I'm going to solve the equivalent equation. So it's going to be 2x squared plus 9x plus 9 is equal to 0. And if I factorise that, I'm going to get 2x plus 3 into x plus 3. Okay, 3 times 3 is 9. 6x plus 3x is 9x, and then we've got 2x squared, which means then my x values are minus 3 and minus 3 halves. And just like I would normally for previous examples, I'm going to sketch the curve. So both negative roots. So I've got minus 3, minus 1.5, x-axis, y-axis, and I'm looking for values of x which are greater than or equal to 0. So again, I'm looking at either side of my roots. So it's going to be that branch and that branch, which can be depicted with solid circles this time, so I want to include them. And, oh, not in between them. Start again. Either side of them. So that way and that way. To write that as an answer, I want x is less than minus 3, or x is greater than or equal to minus 1.5. And in set notation, it will be x such that x is less than or equal to minus 3, or x such that x is greater than or equal to 1.5. There's one final thing that we need to do here, because this is the solution to this inequality. So I'm just going to go back to the top inequality, because there is a very slight issue. Now, if I go back to this inequality up here, if I plug in x equals minus 3, the denominator over here would be 0. And that's an issue because 3 divided by 0 is not less than 2, or less than or equal to 2. So actually, although x equals minus 3 was a solution to this inequality, it is not a solution to this inequality. So to answer the question, I now need to exclude minus 3. So I'm going to have x is less than minus 3, or x is greater than or equal to minus 1.5. And I can include the 1.5 because there are no issues there. And in set notation, it would be x such that x is strictly less than minus 3, or x such that x is greater than or equal to minus 1.5. So when you have a question like this, where it's really odd, I mean, you've got a denominator as a variable here, then you just need to be really careful with the final answer, because if you left it as this, you would indeed lose a mark, because minus 3 does not satisfy this inequality. So you need to be really careful. Okay. Yeah, that's all I wanted to talk about. Question 4 is going to be a hardest one. There are other methods to solve these, but these are hopefully some good techniques to give you a good way to solve them yourself. Right, thanks for watching.